Have you ever wondered if our planet has wounds, scars that tell a story of immense power and time? Look closely, and you will find them. They are not made of flesh and blood, but of rock and soil. These are the Earth's remarkable blood craters, vast, circular depressions that appear as if they are bleeding. They are a breathtaking sight, a vivid reminder of the dynamic and sometimes violent forces that have shaped our world. These natural wonders capture the imagination, drawing us in to question their origins and the secrets they hold deep within their reddish basins, a silent testament to a history written in stone. A blood crater is a truly special kind of impact crater. Millions of years ago, a visitor from space, perhaps an asteroid or a comet, would have collided with our planet. The impact was enormous, so powerful it vaporized rock and carved out a massive bowl in the Earth's surface. But what makes these craters so unique is not just their dramatic creation. It is the story that unfolds afterwards, over countless millennia. The rock and soil left behind are rich in specific minerals, particularly iron. This iron is the key to their extraordinary appearance, waiting patiently for the right conditions to reveal its true, spectacular color to the world. These incredible formations are not found just anywhere on our planet. They are typically discovered in ancient arid landscapes where the forces of erosion have been slow and patient. Places like the starkly beautiful deserts of Australia or the remote, windswept plains of certain parts of Africa are ideal homes for them. In these dry environments, the evidence of the ancient impact is preserved with remarkable clarity. The lack of dense vegetation and heavy rainfall means that the crater's shape and its unique mineral composition remain largely undisturbed, offering a clear window into a distant, cataclysmic past. The journey to find a blood crater is often an adventure in itself. It takes us to some of the most isolated and seemingly inhospitable corners of our world. These are places where the silence is profound, broken only by the whisper of the wind across ancient rock. Standing on the rim of one of these giant reddish bowls, you can feel the immense scale of both time and space. It is a humbling experience, connecting us directly to the cosmic events that have sculpted not only our planet's surface, but also the very course of life upon it, a powerful and moving encounter with Earth's deep history. So why do these craters blush such a deep crimson red? The secret lies in a simple yet fascinating chemical process. The rocks and soil in these specific locations are incredibly rich in iron compounds. For a very long time, this iron lay dormant, locked away within the stone. But over millions of years, it has been slowly exposed to the elements. The most important of these is oxygen, the very air that we breathe. When iron meets oxygen and a little bit of moisture, a transformation occurs. It's a process we are all familiar with in our daily lives, though on a much, much grander scale. This process is called oxidation, but we know it more commonly as rusting. Just like an old iron gate or a forgotten nail develops a reddish-brown coat, the iron in the crater's soil also rusts. Over unimaginable stretches of time, this slow, steady rusting has stained the entire landscape. Every grain of sand and every fragment of rock within the crater has been tinged with iron oxide. This is what gives the blood craters their signature, startling color. It is not blood, of course, but the slow, patient breath of our planet's atmosphere working on its ancient iron-rich wounds. The intensity of the red color can tell a story all on its own. It speaks of the specific type of rock that was shattered by the impact and the exact conditions that followed. Some craters might display a brighter, almost orange hue, while others deepen into a dark, blood-like red. This variation depends on the amount of iron present and how much water has been involved in the oxidation process over the ages. Geologists can study these subtle differences in color to understand the crater's unique history, reading the landscape like the pages of an ancient book written in rust and stone. It is a wonderful piece of natural artistry, an event of cosmic violence. A collision that shook the very foundations of the Earth has ultimately resulted in a place of quiet and profound beauty. The red color is a slow-burning fire that has taken millions of years to spread across the land. It serves as a powerful visual reminder that our planet is not a static ball of rock. It is a living, breathing system where chemistry and geology are constantly at work, painting vast and breathtaking canvases that we are only just beginning to fully appreciate and understand. Now let us turn our gaze upwards, from the sunken bowls of the craters to the towering masses of the highlands. Highlands are vast areas of elevated land, like mountains or plateaus, that rise dramatically above the surrounding plains. Unlike a single sharp mountain peak, Highlands are often extensive regions of rugged rolling terrain. They are defined by their sheer altitude and their complex topography, a world of deep valleys, high ridges, and broad, windswept plateaus. These are landscapes sculpted by immense geological forces from deep within the earth, pushed upwards over millions of years by the slow, powerful movement of tectonic plates. Highlands are fundamentally different from other landforms like lowlands or coastal plains. Their elevation has a profound impact on their environment. The air is thinner and cooler, and the weather can be far more extreme and unpredictable. This creates unique ecosystems, where only the hardiest plants and animals can survive. The steep slopes and deep valleys of the highlands also mean that they are constantly being shaped by the powerful forces of erosion, such as water and ice. Glaciers carve out U-shaped valleys, and rivers cut deep gorges, creating a landscape that is both ancient and perpetually changing. You can find these magnificent highlands all across our planet, each with its own distinct character. Think of the breathtaking Scottish Highlands with their misty lochs and heather-covered moors, a landscape steeped in myth and history. Or consider the vast Tibetan Plateau in Asia, often called the roof of the world, a high-altitude desert that is the largest and highest plateau on Earth. Even the rugged highlands of Ethiopia in Africa represent another stunning example, a place of deep canyons and unique wildlife found nowhere else on the planet. Each highland region is a world unto itself. Life in the highlands presents a unique set of challenges and opportunities. The soil is often thin and rocky, making agriculture difficult. Yet for centuries, human communities have adapted to these demanding environments, developing unique cultures and ways of life. The highlands are also vital sources of water for the lowlands below. The snow and rain that fall on their high peaks feed the great rivers of the world, making these elevated landscapes critically important for countless ecosystems and human populations far downstream. They are the great water towers of our planet, essential to life. Why do we, as scientists and explorers, feel such a pull towards these remote blood craters and highlands? It is because they are natural laboratories, places that hold vital clues to understanding our own planet and others. By studying the structure of a blood crater, geologists can learn about the physics of high-speed impacts. This helps us understand the history of collisions on Earth and what might happen if such an event were to occur in the future. The unique iron-rich mineralogy also provides a perfect testing ground for equipment destined for other worlds, like the planet Mars. The red planet Mars is famously covered in iron oxide dust, which is why it appears red. The blood craters on Earth are one of our best analogs for the Martian surface. By studying the geology and potential for life in these earthbound craters, scientists can refine their search for signs of past or present life on Mars. They can test rovers, drills, and life detection instruments in a similar environment before sending them on their long journey through space. These earthly craters are, in a very real sense, a dress rehearsal for one of the most exciting quests in human history, the search for extraterrestrial life. The highlands, too, are incredibly important for science. Their ancient rocks can be billions of years old, providing a record of Earth's deep geological history. By studying the layers of rock, scientists can read the story of past climates, volcanic eruptions, and the slow drift of continents. Furthermore, the unique ecosystems found at high altitudes are sensitive barometers of climate change. As the world warms, we can observe changes in the plant and animal life of the highlands, giving us an early warning about the impacts on a global scale. They are sentinels, standing guard and telling us about the health of our planet. And so, from the deep red wounds of the craters to the majestic windswept heights of the highlands, our Earth is constantly revealing its secrets. These landscapes are more than just beautiful scenery. They are a source of knowledge and a well of inspiration. They teach us about our planet's violent past and its delicate present. They help us reach for the stars, preparing us for journeys to other worlds. As we continue to explore these incredible places, we learn not only about rock and wind, but about our own place in the universe. And that is a journey of discovery that is truly endless and full of wonder.